So under Introduction to Computers, I spoke to you about the language C++. Let's go on. We'll be talking about programming and problem solving, and I'll be talking about an introduction to C++ programming, which is not an introduction really. We've done this already, right? And testing and debugging. Testing and debugging, one of the issues with testing and debugging was that you missed out a semicolon, or you mispronounced or not mispronounced, you misspelled C out. Instead of C out, you had C in, or instead of C in, you had N line, and you misspelled that incorrectly, right? So what's a computer program? A computer program is basically a set of instructions for the computer to follow, right? The computer follows the instructions, and the computer says, listen, I need to input a variable, or I need to do some processing. For instance, in our terms of our computers, our processing was multiply numbers 1 times 2 times 3 times 4 times 5 times 6. Well, we stopped at 5, didn't we? And that was 120. Computer software, that's the nuts and bolts of what you came to learn about, right? Programming aspect, and the language that we're talking about is C++. A computer software is basically a collection of programs, and the program that I'm teaching you is C++. These are editors, translators, system managers, and in our case, code blocks. A high-level computer programming language is C++. That's what I'm teaching you, C++. Java, Lisp, Schema, Visual Basic, all those go with it. Why we talk about it being a high-level language is that the language resembles quite closely our English, right? That's why it's a high-level language, right? And a lower-level language would be closer to machine language or assembler language. Now, I'm not going to get into that. Our purposes, it's simply C++. Right, let's go on. A compiler. Now, in order for me to translate or convert what I am talking in English to my programming language, and then for the computer to understand it, we need what is known as a compiler. Right? There's something called source code. You can read through that, object code. All I'm interested in is, can you write in code, C++, and convert, and the compiler does it for me. What's an algorithm? An algorithm is basically a sequence of precise instructions which leads to a solution. So if I had to talk in general of, here's my cup of tea that I made. Here's my cup of tea. I'm not sure if you can see it. In order to make a cup of tea, I need hot water, I need a tea bag, I need sugar, I need milk. And I have a particular step in order to do that, right? The way I'm going to make this cup of tea. First step is to boil the water. Second step would be to put the tea bag in the cup. Third step would put the hot water into the cup. Then I put the sugar, I'm going to stir it, put the milk, stir it, let it soak for a while, and then I'm going to drink the tea. So that's a sequence of steps or instructions. That's what an algorithm is all about. Or another word for an algorithm is a recipe. A program is similar to this. I've already introduced you to a program, and C++ is the program language, and we had to display hello world. That's a task. Now that was simply an output to the screen. Then I asked you to do multiply 1 times 2 times 3 times 4 times 5, and I got there to be 120. Right, 120. Okay. Okay, let's close the camera. Right. So, how's it going to do this afterwards? Oh, it won't be long because you're recording you on this. Oh, right. Okay. So, an algorithm is expressed in a language that the computer can understand. I spoke to you about that. Let's go on. Right. Program design. So programming, in order to do a program, like I gave you the example of finding the product of 1 times 2 times 3 times 4 times 5, and I got 120. Now, Dia had used the for loop, and Karov and Mark used 1 times 2 times 3 times 4 times 5. So that's what I mean by a creative process. You can use 2 or 3 different methods, but you must get the same answer at the end of it all. But for our purposes, I said KIS, keep it simple. I wanted you to only use C out, C multiplied it, and I said 1 times, what was it? 1 times 2 times 3 times 4, and so forth, right? And right, let's do that. Let's see. Right, so I said 1 times 2 times 3 times 4 times 5, and it's got the value of 120, and I was so lucky that that's what it is. Oops. Right, I was so happy that it's got 120, but I could have used a for loop in order to do that, right? Program design, I spoke to you about that. You can have various ways of getting to the same answer. Some of you use a for loop, some of you do not use a for loop. I like programming to be simple. Keep it simple. We'll come back to this, right? Right. What is input? Input, like I told you this morning, is what goes into the program, right? Information is output. What comes out is output. Processing takes place where I multiply 1 times 2 times 3 times 4 times 5 times 6 times. Oh, no, I stopped it. Have that. And I'm having the answer of 120. Right, let's go on. Develop an algorithm before implementation. So if I had to now determine that I wanted the answer of 120, I got to think back and say, how am I going to get 120 as the output? I got to take 1, multiply it by 2, multiply it by 3, multiply it by 4, multiply it by 5, and I'm going to come up with 120. Right? And now that was a very simple program that we'd used. We could make it a little more complicated as we're going along. Oh, let's talk about that weighted test for correctness. You need to work it out before you get the answer. And that's why I wanted you guys to use the compiler or to know the maths behind it. Right? Right. Let's run the program. Okay, we'll come back to that when you get a little bit more in depth. Right, so you can go and read all of this. This is a history lesson where C++ came from, C programming, what does the plus plus mean, and the history of C programming. And oh, there's the programmer. Well, we've got to give him some credit. What were some of the shortcomings of C programming? And last year, some of you may have done C programming. I know there's some repeat students in this class. And listen, I understand you all did C, but I want to move one up, C++ programming. So here's the very simple C++ program that we had. Include IO stream using namespace std int main. And at the end of it all, it says return 0 with a close curly bracket. Now, can I use my little markers out here? Ah, there we go. There's my laser point. You'll notice there's my curly bracket out here. My curly bracket basically tells me that I'm starting my program, and the curly bracket at the end says that I'm at the end of it all. Inside is my program statements, And when we get to declare variables, I'm going to talk to you about integers and Boolean and characters and real values and so forth, right? I think you all know about namespace now. If we don't have using namespace std, then I could not use endline. We tried that out already. And if I didn't use namespace, I could not use, I had to put an std : C out. All right. So now that I have using namespace standard, I can use all the libraries from that namespace. I can use endline, and I don't have to put std in front of C out. All right. Variables. Now, we haven't spoken about variables yet, but the next lesson, in fact, if I have time, what's the time like now? Where's my clock? I always like to keep my clock next to me. I'm going to do a program in C++, and I'm going to in code blocks, and we're going to have a variable being declared out there. So in this case, the variable is number of pods, P's per pod, and total P's, and I got a semicolon out there. Right? Okay. 1 second here. What? Constance? Lisa? I'm in the lecture. Yes, miss. Constance? Thank you. Lisa, you got the possible audio. Right. I'm sorry about that. Okay, so here we go. So here's a variable declaration. So I'm going to give you some rules regarding variables. Right? Let's go to that. Let's see if I can have a program out here to show you what I mean by some rules regarding variables. Now, just like we have names, right? We have names. Our name is, okay, you all know my name by now, Prinavin Govender, right? My name is Prinavin Govender, and in my name, I don't have Prinavin 1, Prinavin 2, or Prinavin with a hyphen or a dollar sign or anything of that, right? I don't have that. Now, certain rules apply to variables as well. If you are declaring a variable, keep this in mind. You can't have a variable declared as the number 2, right, or 4. If you have a variable being declared, you can't have a special character or you can't have a reserved word. So I cannot declare a variable to be called return, or I cannot have a variable declared to be called cout. You get it? That's what I mean by rules declaring with variables. And that's a definite question for the next assessment. By the way, I'm going to tell you about the test where it's doing, right? So, integers, right? Integers, variable declaration, right? So here we go. Program statement, cout, press return after entering in a number. We've already tried our cout statement. Cout said cout hello world. Okay, cout, that's fine. You know how to pronounce that. And right. So we've done this in class, so that's fine with you, right? Now, cin. Cin stands for console input. I need to basically, I basically need to obtain a value from the user. That's what cin. And I'm going to store that in a variable. And I'm going to try that out. Well, it's 2:20. At about 2:30, I should be able to do a program where I'm declaring a variable and I'm requesting you to do something with that variable. I think if some of you tried out the age program, and I said cin age, and I asked you for the age, and it said that's a great age to be, that was the program that dealt with this. Okay, so let's go on. Cin is used for input from the keyboard. Now, any computer program, and I've been doing programming for a very, very long time. 1986, actually, 1986. That's how long I am. I don't think some of you are born out there, right? And see, this is where I miss having a face-to-face class, in that I could see your laugh, smile, and there's this interaction. Right now, I don't have that with you, right? Let me put the light on out here. I need to see some. Right. There we go. Right. Let's go on. So, cin extracts data from the keyboard. Think of cin as a name for the keyboard. Yeah, I can think I'll read that out, and it points from the keyboard to a variable. Go on. Let's go on. Right. So here's the total P's. Look at the way total P's has been written. in one word. So there's a rule about a variable declaration. A variable must have one, in fact, one long name or short name or whatever. But I cannot have a space in between that variable. So total, I cannot have space P's. I'm going to say total underscore P's. So it abides by the rule about variables that it is one word. So P is number of pods times P's per pod. So if I have 3 pods and in each pod there's 5 P's, I should have 5 times 3 is 15 P's in total. I don't know if you like P's or not, but I like P's, right? Let's go on. And I perform a computation. I already did this with you. We said 1 times 2 times 3 times 4 times 5, and I got the answer of 120. There's my input processing output. That's all you're going to think about right now. Input processing output. The equal to sign causes the total piece to get a value. Now, when we talk about variables, we're talking about allocating a value to a variable. It's not the maths that we are interested in. When I talk about sum is equal to sum plus mark, that's a memory allocation. I'm just putting it out there. I'm going to include that for you in the next couple of programming lessons or two, right? But it's not in mathematics. Sum is not equal to sum plus mark. That doesn't make sense mathematically. But we're not talking a mathematical equation. We're talking a memory location. Right? So here's my program statement. C out number of pods. And I think you know what that fast forward button is. Right? We call it the insertion. And we're inserting in number of pods or whatever the case might be. Right? Let's go on. A compiler, we say compiler accepts almost any pattern of lines, breaks, and indentation. Now, even if we leave blank lines and blank spaces, that's okay. That's okay. The compiler finds it's all right. That's not a problem. Programmers format so that they are easy to read. This morning, I spoke to you in class and I mentioned to you having comment statements. That enables us to make the program a little more readable for someone who has to look at your program. You know what is your abbreviations are, but a brand new person looking at it may not be able to know that, right? Here's my opening and closing braces. I call it my curly brackets, right? Indenting statements. Indenting statements mean that I'm not starting everything on the left-hand margin. Some are moved to the right, some are moved in between, middle, all of that goes with it, right? We only use one statement per line. I like that, right? And every time we make some change or edit to our program, we compile the program. But when I get to having longer and longer programs, I'll talk more about that. Variables are declared before they're used. Now, this is an important point in C++ programming. We declare a variable before we use it, right? So it's like if you're going to the airport and you're traveling somewhere and they ask you, are you carrying any dangerous goods with you, right? You got to declare it. Are you? I know, not that I went overseas or anything like that. I don't even have my passport yet. Or they'll ask you something like, maybe, do you have any drugs on you? Not that you're going to say yes now, right? You should not be carrying that now. Oops, and I'm recording this. Boy, oh boy. Oh, man. I've got to show you the reactions as well on MS Teams classes, right? So the important point is we declare a variable before we use it. I'm going to have a program now. There's that include IO stream, include directives. It tells the compiler where to find the information about the item that we are going to be using. So let's say, for instance, namespace. I want to include using namespace. I'm basically telling the computer, please go to this library and look for what does cout mean, right? Right. So that's what the library is all about. We'll talk about that. Here we go, using namespace. It tells the compiler to use the names in the IO stream in a standard way. That's what std basically stands for as well. Okay. Let's see, we begin the main function. You know that. The main function is the main man, int main, and we end the program with the close curly bracket. The open curly bracket and the close curly bracket. The main function ends with a return statement. Now, I just overlooked that yesterday and last week where I spoke about return 0, but that we talk about in terms of when we want to return something. I'll come back to that in a more complicated program. But for now, take it nice and slow. C++ program code is written with the text, text editor. The online compiler as well uses a text editor. You can read all of that. How do we run a program? We've run a program, we've compiled a program, so I'm not going to go through that. You've seen that working. Right, so that's it. Describe the output of the right. C out, you've done that, that's easy. What does C in piece per pod do? All right, I'm sorry about that. I think I lost you for a little bit there. I lost you for a little bit. Hello, have I lost you? I'm back online. Somebody please. I'm sorry. Thank you. Right, I'm sorry about that. I've got two Wi-Fi's running on my at home, and I think it switched from one to the other. All right. Now these are all the issues that we have when we are online. Please tell me if you can see my screen. Right, it says describe the output of this line. C++ is easy to understand. Explain what this line does. Great. Okay, so we'll testing and debugging. A bug in a computer program is basically a mistake. So if you type in CUT, cut, instead of C out, that's a mistake in spelling, right? Debugging is where you go to look for errors to ensure that your compiler can run. That's what debugging is all about, right? You can read about program. This is important. Syntax errors, runtime errors, and logic errors. Syntax error is where you make a mistake in the grammar or the spelling of the program. That's easy to correct. Like this morning, I may have missed out the semicolon. That's an error in syntax. Runtime error is an error that occurs when the program is running, and the famous runtime error is division by 0. A logic error is an error where I asked you to multiply 1 times 2 times 3 times 4 times 5 to get 120. You go and do something else. You say 1 plus 2 plus 3 plus 4 plus 5. That's an error in logic. The program doesn't have any syntax errors. The program is running, but the program has logic errors in it, right? Okay, right. Now, let's go to our program. Oopsie, right.